What's up everybody? In this video, we are going to learn how to connect a slide switch to the Arduino and create a mechanical on-off switch for a circuit. When the switch is on, electrons will flow through the components in the circuit. When the switch is off, it will interrupt the flow of electrons and the components will not work. Start off by logging into Tinkercad using your course username. Select Circuits in the menu under your designs. You will see our LED-push button circuit that we made in an earlier video. Hover over the circuit and click on the gear in the top right-hand corner. Select Duplicate. Click the name of our circuit in the top left corner and change the name to Slideswitch-on/off. Select a slide switch from the components and add it to your artboard right below the red power wire that connects to the breadboard. The slide switch is also known as a single-pole, double-throw SPDT switch. A slide switch has 3 pins. If you hover over each one, you will see Terminal 1, Common, and Terminal 2. The common terminal is shared with both sides. When you move the switch to either side, you complete the connection to that terminal. To make a mechanical on-off switch for our circuit, we need to ensure that we interrupt the flow of electrons for the entire circuit. Normally, the best way to do this is to interrupt one of the wires that is closest to the power supply. On our circuit, we can interrupt the power wire that runs from the Arduino to the breadboard. Click on the red wire that connects the 5-volt from the Arduino to the breadboard, and connect it to the common terminal on the slide switch. Next, add a wire from terminal 1 to the plus or power rail on the breadboard. Great! We have connected our slide switch. Click Start Simulation. When the slide switch is flipped to the side that connects the common and terminal 1, we complete the circuit and electrons will flow through the components. Doing so means that our button and LEDs work. When we flip the slide switch to the terminal without a wire connected to it, we interrupt the flow of electrons in our circuit and no power flows to the components. Let's look at one more thing. Click on the code button to access your code. Uncomment both of the serial.println statements in your loop function. Click Start Simulation and ensure the serial monitor is displayed. Turn the switch to off. You will see that the components of your circuit are not working, but the code in the Arduino is still executing through the program loop. So why is this happening? While we have cut the flow of electrons to our breadboard, Tinkercad is still supplying power to the Arduino from a USB cable. If you were to build this circuit in real life, if you wanted to ensure all power was off, you would need to power the Arduino with an external power source, like a battery, and interrupt the flow of electrons from the battery to the Arduino. At the end of this video, you should have a better understanding of how to make a mechanical on-off switch.